So we'll start the day by learning about a tool called the periodic table of life and how, as a community, we can help them build it. So I want to welcome Colleen Unsworth up here, and she will be presenting with Brandon Ruffridge and Alex Rulevsky. Thanks, Colleen.
Good morning. I appreciate this box so I can see. So I want to say thank you again for everyone to show up today to this wonderful event that I'm grateful to be a part of again, this year in a few different roles than previous years. As Tricia mentioned, this morning I'll be presenting a little introduction to the periodic table of life, and also joined with me are a couple of my team members to talk about some of the different aspects of PeTaL. I've seen PeTaL through many different phases over the past 5 years of my Biomimicry fellowship with NASA, and many of you may have heard of PeTaL already. It is the brainchild of Dr. Vic Shyam, who many of you may know also. And for those of you who haven't, the periodic table of life is envisioned to be a comprehensive AI design tool to help facilitate the biomimicry process for practitioners from all different disciplines. And a fun little story about PeTaL that I don't know that anyone's heard before is that when I first started at NASA in 2017, I went up to Glenn for the first time as a baby little grad student and met Vic in his office in Building 5. And he was telling me all about PeTaL, which at that point was still like in the conceptualization phase, you know? And if anyone knows Vic, he has like these wonderful, like big visionary ideas, but you know, there wasn't anything super tangible yet. And so I'm asking him, and I'm trying to like casually clarify like what PeTaL is and what it's supposed to be. You know, and he just kept saying, yeah, it's a periodic table of life. So I wrote in my notes to Google periodic table of life and figure out what a periodic table of life is. And, you know, 5 years later, we're still trying to figure that out. No, but in all seriousness, there are lots of biomimicry tools out there already, but the way PeTaL is intended to be different and useful is we're trying to bring integrate lots of the different tools that already exist together to help facilitate the biomimicry process from, you know, ideation and problem conception all the way through application. And different parts of the project are at different phases of development, but we have lots of different aspects that hopefully will seamlessly work together in the future. So one of our big goals too is to expand the corpus, or basically the knowledge base that we're pulling from, for lots of different types of data from lots of different sources. And then we're going to leverage AI and machine learning to be able to do some predictive modeling and really understand the data that they're pulling from better. So the demo today we're showing only shows just a piece of our journey. But over the years, we've made many different strides in lots of different areas, and I want to acknowledge all the work that's been done, especially through internships and volunteers helping with the PeTaL project. We've had over 30 interns and volunteers over the past few years, as well as have partnered with some big organizations, including Biomimicry Institute, Ask Nature, as well as obviously University of Akron has supported a lot through the fellowship program. So since its inception, you know, we've had lots of great progress on lots of different aspects that I personally don't understand too well, a lot of data science. That's why I have some of my team members helping me present today. So like I'd mentioned, PeTaL, I should maybe slip. Like I mentioned, PeTaL has lots of different facets, and one of our big drivers is to integrate the different tools that exist. So we've been working with lots of different tool developers to try to help these discrete tools to be able to work together and help facilitate the process for people from a wide range of disciplines. So we'd like to specifically highlight the value of the Dr. Jacqueline Nagel, who I believe is online, her Engineering to Biology Thesaurus, which helps to translate between biology and engineering in technical ways, which is really important as we're trying to collaborate on biomimicry projects. PeTaL is also envisioned to be centered around an ontological framework. We pulled a lot of our inspiration and were influenced by Julian Vincent's biomimetic ontology. We'd also like to acknowledge Biomol, which was introduced to us by Dr. Marianne Egermont, who I believe is also online and helped organize a lot of this conference this week, as well as recently the Pattern Alphabet, led by Alex Wolf and Dr. Vijal Parikh. They've recently let me know that they are working to create a font, basically using spatial patterns to try to conceptualize natural phenomena as opposed to normal language. So another way for people to access nature. And it's genius for us to mimic. So overall, PeTaL has many lofty goals that we are working towards. And although we're only sharing a relatively small piece of our journey with you today for you to demo, Brandon's going to show you in a little bit, we're looking forward to sharing with you, and we're open to any feedback you might have on the tool itself, but also, the process and how a user might interact with our tool. So I'm going to pass virtually the mic over to Dr. Alex Rulevsky, who has graciously agreed to help us present. She's in Seattle, so it's barely 6 a.m. there. So we thank Alex for joining us this morning and turning on her camera for us. So I will get to your slide, Alex.
Awesome. Thank you so much, Colleen. It's a pleasure to be here to present. So before we started building PeTaL, we really wanted to make sure that we understood our audience and our users. And so we segmented our audience into 5 different personas. The first and second personas actually are our engineers. And the major difference between them is that we have engineers who do or do not have prior biomimicry knowledge or expertise. But they're mainly problem-driven and problem-focused. So Colleen, you can just go through all 5. Perfect. The third and fourth personas are biologists. The biologist that's interested in seeing what their research or their organism of study can inspire. So they're more solution-driven. Our fourth persona is a biologist who has data that they want to contribute to PeTaL. And our fifth persona, our main audience segmentation, is an educator who might want to use PeTaL as an exploratory or inspirational tool. So ultimately, we found that our largest audience, and the one that we want to test PeTaL with primarily, was the first type of user, that engineer without prior biomimicry knowledge. And so we made a customer journey map to see what their journey using the tool might look like. So here we have Creative Kim. She's an engineer who loves finding creative solutions. She's practical, but she's not afraid to try new ideas. And she's looking for a creative solution to the problem of overheating in a rocket turbine. So she has to present her findings to her colleagues in 2 weeks, and she needs to quickly find biological solutions and understand their relevance to her problem. But she has limited knowledge of biology and no prior knowledge of PeTaL. And so we broke her journey down into 5 user stages, each comprising a different set of actions and a time estimate for each stage, as you can see here. And what's great for those of you that are familiar with the biomimicry process is that you'll see that this user journey actually unfolds very similarly to the steps in the biomimicry process itself. So you'll see that the discover phase is equal to, or similar to the problem analysis and abstracting a technical problem, etc. Right? And so down at the bottom, you'll see that we're also able to map all of these different phases to the PeTaL project itself and, how we wanted the project to unfold. And so you'll see that, with phase 1, we actually wanted to focus most on research and learning for the user, while phases 2 and 3 of the PeTaL project, we more wanted to focus on, the additional phases of the biomimicry process until we ideally cover the whole biomimicry process from start to finish. And so once we had mapped this out and understood this better, it was easier for us to understand exactly what parts of PeTaL we wanted to focus on. And we realized that was actually helping users with their research and learning. And so to do that, we turned to machine learning to help us, classify and label relevant biomimicry papers for our users. And so to talk more about that, I'm going to hand it over to Brandon.
Okay, thanks, Alex. So one of the first steps that we took is we wanted to help connect engineers to nature-inspired solutions. And so we thought, well, how are we going to do that? There's so many different natural species and different solutions that they've developed over millions and millions of years. And the way we thought we could approach this is by categorizing the solutions that nature has come up with into different categories that might help these engineers. So that's the essential goal that we had. The other problem we ran into was it takes a lot of time to categorize these research papers into their nature-inspired solution categories. And there's been a lot of work to do that, but it's very time-consuming, and you can't possibly hope to process all the papers in a reasonable amount of time. So we're using machine learning to teach a computer algorithm how to do that categorization by first showing it examples of papers and their related solution. And then it can then learn, oh, this is what a paper about thermal management looks like. And then it can learn to accurately predict the category that a research paper should fall within. So we were really excited that Ask Nature had already developed a well-curated set of research papers and their categories. They already had a really great set of categories. And then along with Alex and some others, we developed what we call the PeTaL taxonomy, which is a hierarchy of categories. So it starts out really general, something like move, how does nature move? And then we go and break that down into level 2 and level 3 categories. So at the third level, we'll have a very specific category, such as how does nature actively move through a liquid? So we've got 100 of these very granular categories, and our ultimate goal is to build a machine learning model that can parse papers and put them into their respective categories that they should fall within. Once again, thank you to Ask Nature as well as the Allen Institute of AI for their help with the machine learning algorithm and their guidance with our team. And I would just like to take a moment to show you our website. We have put a website together. It's PeTaLAI.org. And what you'll find there is we were able to create this machine learning algorithm, and we were able to categorize about 1,300 papers. And it's very simple at the moment, but the idea is that we'll add to this over time as we get feedback from people using it, what's working well for them, what would they like to see. So you simply would pick one of the categories. You can see the level 2 category here. This is all related to active movement, and then these are the level 3 categories, that what we're calling level 3. These are the granular categories, and we currently only have 29 in here, so we don't have the full taxonomy yet. But if you pick one, let's just pick actively move through liquids, it will pull up the results from our machine learning algorithm. So these are ranked by what the machine learning algorithm thought were the most, the paper that was the most related to that particular category, such as Google would do when you enter a search term. It tries to rank things. And so you can kind of scroll through here and read the title of the paper, the abstract, and hopefully, you know, as someone who's trying to solve a problem, you might get some insight into potential species that may have a solution to the problem you're looking to solve. So we do have a fair number of things in here, category-wise. How does nature manage stress and strain? So different engineering-related problems, optimizing shape. So yeah, we really want people to start taking a look at this and providing us feedback. We'll have a slide on that coming up. So with that, I think we're going to turn it over now to Herb Schilling, who's going to talk to us a little more about how we're getting more data for our machine learning model. Thank you.
Right. Thanks, Brandon. So as Brandon said, part of what we need to do to train this machine learning model is some pre-labeled documents, and we had roughly 1,500 of those. But the more labeled papers that you have, especially spread across all the different categories, the better the result in terms of training the machine learning model. So the question is how to do that. And was the slide supposed to be advanced? I'm not seeing the slide. That's better. Thank you. So one of the ways we can do this is through crowdsourcing. And one of the services that we're allowed to use through NASA for this kind of work is Amazon Mechanical Turk. So it took a while to actually get access to it. And we tried it. For those of you who aren't familiar, you basically post work online for people to do work, and really anybody in the world can become a worker, a mechanical Turk worker. So we did that, initially just posted out there for anybody to work on. That did work really well, as you probably could guess, because these are biology papers and you have to have specific knowledge to label them correctly. You can do some other things to find only qualified people using some statistics that Amazon keeps track of for the use of the workers. You do some pre-testing to find the good ones. We did some of that, and still didn't really work well. And plus there were other issues with Mechanical Turk, as I list there in the cons section. So, but luckily lately Amazon came up with a new service called Amazon SageMaker Ground Truth. And in that service, there are 3 different types of workers that you can use to help with your labeling jobs. And one of them is the Mechanical Turk workers again. And we didn't pursue that because we knew that wasn't working very well. You can also use private internal. So for example, just as a test, we used Colleen and a few other people to just try out the service. They don't get paid through that, but it's a way to use the ground truth service as a way to collect data. But the way that we really wanted to use ground truth was through some vetted third-party services that do labeling as their job. So recently we were connected with one of those, and we gave them 28 papers that were pre-labeled, and the results were much, much better. At least half of them, they really got perfectly. There's still some issues with the other ones, but we just started, and this whole thing's an iterative process. We have some ideas on how to improve things. So we think that going forward, this is a good way to get more labeled data. That's pretty much all I have to say. So that's the end of my part of the talk.
Thank you, Herb. So I'm just going to quickly wrap up and talk about where we want to take PeTaL in the future. So in the future, we do want to start integrating some more of the computer vision, so we can start to, use it, leveraging the AI as such a unique way to, approach a biomimicry tool. And I believe that we can really expand our corpus, really pull from really expansive data sources to get some deeper insight into different natural models we can mimic. We want to, of course, look for different convergence across different taxa of animals, as well as find new and efficient ways to be able to visualize the data that we're pulling from, as well as, the long-term vision is to have other kinds of really models such as CAD models that can really help an engineer tangibly understand how they can use what they're finding in the literature to inspire solutions that are relevant to their problems. And later on, another aspect that we thought would be neat would be to have information on patents that were related to similar types of models and engineered solutions that already exist. And I'd like to mention that PeTaL is open source. Everything, we want it to be collaborative. We want, to just help biomimicry practitioners come together and work towards common goals. And actually, the website that Brandon showed, we'll be using that. It'll be set up on some computers during the design fiction workshop later. so that you guys can test it out. You can, of course, just go to the website as well. I'm just going to click to the next slide. It summarizes the ways that you can get involved, and we are open to questions. So thank you so much.
So do we have any questions from the audience or Britt? Okay. Have any got questions?
In your list of engineering terms, I did see thermal energy. I teach thermodynamics, and when I saw your list, I felt neglected.
You know what, you're not. It's interesting. Brandon showed, I think, just the specificity of level 2, but deeper in level 3, we have some specific labels for managing. Well, we phrase it as like protect against temperature. It falls into the larger categories that may not have been represented. But if you click through later, I think you can see all the way through level 3. I believe so. Yeah. So we do have temperature. I know, especially for my advisor, Vic, he's really does a lot with thermal management. So, of course, we made sure to incorporate that.
So also an engineer, and I was curious, I wasn't seeing too many visuals on some of those abstracts in PeTaL, and I don't know whether that's like a thing from like journals or an artifact of how you're presenting it, but I find it's nice to have a visual just to like get the idea and kind of have a reference for what all big jargon is talking about.
It's tricky because like even pulling just the text and doing the machine learning to recognize relevant text is a lot, right? And this is, of course, just our first version. But that's the kind of feedback that's important, I think, for people with different backgrounds, so that we can maybe prioritize that as we integrate more visuals into our data visualization. So thank you. I appreciate everyone's feedback. We'll be around, of course, if you want to ask any follow-up questions or share your comments later. So thank you all.